Welcome to this session on handling asynchronicity in payments. As more customers dramatically increase their online spending, offering diverse global and local payment methods is essential to doing business in the internet economy. For example, in Europe, only 40% of online transactions are made with cards. Local payment methods such as Ideal in the Netherlands, SEPA Debit in Germany, or Bax Debit in the UK are all popular ways to pay. As this payments landscape grows, so does the complexity. One of those complexities is asynchronicity in payment systems. In this session, you'll learn how to build a webhook endpoint to listen for asynchronous events and fulfill orders or provision your service using Ruby and the Stripe VS Code extension, which is underpinned by the Stripe CLI. Let's get to it. Imagine you're selling book subscriptions to folks in the UK and they'd like to use Bax Debit to make recurring payments. Bax is a delayed notification payment method that can take 3 to 6 days to know if a successful payment was made, depending on some factors. I'll grab a payment link for that recurring price in the dashboard. We'll copy and follow that payment link to check out with Bax Debit. Let's fill out the details and check out. Bax Debit requires that the customer provides a mandate that allows you to debit their account. Let's complete the subscription. Great, but as we learned earlier, a Bax payment can take from 3 to 6 days to clear. We'll be notified about the successful payment event asynchronously, so we'll need a mechanism to listen for that event and fulfill the service. Let's build a webhook endpoint to do exactly that. I'm starting with the basic Sinatra project and I've set up some gems including .env to manage environment variables. .env will initialize the required variables for this project, namely the secret key for making requests to the API and a webhook secret which we'll see how to use later. I've also installed the Stripe VS Code extension. Next we'll install Stripe Ruby and bundle it with our project. This will give us the classes and methods to process incoming events. Now that we have Stripe Ruby installed, let's require it in our project and set up the Stripe API key. As we saw earlier, .env has initialized our environment variables by calling .env.load. Finally, let's start on the main part of the session. We need a route into our system where events can be received using post requests. We'll start with the simplest thing possible and log a posted event out to the console. We'll also respond with a 200. We'll touch on this again later. Let's start the server and post some event data to it. In order for our local server to receive events, you can stream them in real time from Stripe to your local webhook endpoint using the VS Code Stripe extension. We'll supply the URL of our webhook endpoint. Let's trigger the event that we would expect from the checkout session we completed using Bax Debit. That's the checkout session async payment succeeded event. We can see the event data streaming in. The reason that there's multiple events is that the event that we triggered is dependent on other events happening, like a payment intent being created. We can also see the post payloads being logged out of the console. Let's be more specific. Let's only detect checkout session async payment succeeded events when we want to fulfill an order. We'll parse the incoming JSON and then use the construct from method from Stripe Ruby to create the event object and then test for the event type. If it's the right type, let's ring the bell that we made a sale. Let's trigger another event. At this point, you might think, well, anyone can hit the webhook endpoint and create orders, and that's where the webhook secret comes into play. Let's change our code to check to make sure the event really came from Stripe. We'll start by grabbing a special header from the request, specifically the HTTP Stripe signature. This is a signature that Stripe sends along with the event that is calculated using the event data itself and the Stripe webhook secret. That way, only your system and Stripe can verify the contents of the payload. And if you can, you know the event originated in Stripe. We'll use a different method called construct event that does this verification for us. Let's verify it's working again by triggering the event. Stripe expects that when you've successfully received an event that you acknowledge that receipt by responding with a 200 as quickly as possible. That lets Stripe know not to keep sending the event in the case of a blip or an error. Let's handle the case though that the signature does not verify. We'll use the Stripe Ruby signature verification error to handle that case. We can force that error to occur by fudging the webhook secret. We can see that none of the events verify. But let's roll that back. Now you're fully equipped to receive asynchronous events about successful payments and verify the origin of those events. I hope you enjoyed this brief introduction to dealing with async payment events in your system using Ruby and the Stripe VS Code extension. If you'd like to know more, please do subscribe to our Stripe Developers YouTube channel. Look us up at Stripe Dev on Twitter. My handle is mattling_dev, or you can join the conversation on our Stripe Discord server. Enjoy the rest of the sessions.